Hi, I'm Brandon Gligor, and I'm from Lincoln Hall in Lincolnwood, Illinois. I'm going into 7th grade. My project is about coating an antibiotic in space, and when you coat something that is microscopic or very small, it is called microencapsulation. I didn't know anything about microencapsulation until I met Dr. Hendrickson at Avika. He is the founder and CEO of the company, and he and Dr. Chris Rube, who is in charge of the research and development, helped me understand microencapsulation and let me use their scanning electron microscope to look at the results from my experiment. Microencapsulation is putting a coating on something, like putting the candy coating on the chocolate for an M&M. I chose to use ciprofloxacin, which is an antibiotic, and polyvinyl pyrrolidone as the polymer coating. I chose these because they were on the safe fly list. My hypothesis is that the ciprofloxacin would be coated more smoothly and more efficiently in microgravity than it would be in gravity. And by efficiently, I mean that more of the coating would get on the ciprofloxacin and less would be wasted. Also, I think there would be less agglomeration in microgravity, which means less sticking together of the particles. A thicker coating and less clumping together may be useful. The thickness of the coating helps the drug be released at the right time, and less sticking together helps the particles be used individually. I thought microencapsulation would happen more efficiently in microgravity because the process would take place more slowly without gravity pulling everything together quickly, and the coating would have time to build up slowly. In gravity, the process would take place faster and would not have as much time to develop, and everything might just sink to the bottom or clump together, causing agglomeration. I chose a concentration of ciprofloxacin to PVP of 1 to 2.5. This means there's 2.5 times more PVP coating than ciprofloxacin drug particles. My mentors at Avika took pictures of different ratios of ciprofloxacin to PVP coating before the experiment took place using a scanning electron microscope and sent me the results to help me decide the ratio to use in space. In this picture done before the experiment in space, there is a 1-to-1 ratio, and I could see that there was too little amount of PVP coating to detect it easily. In this picture done before the experiment in space, there was a 1-to-4 ratio, and I could see that there was too much polymer because you can see excess polymer between the ciprofloxacin particles. So I chose a 1 to 2.5 of ciprofloxacin to PVP because it was between these two preliminary results, and because I didn't want too much PVP because it might be hard to tell how well the ciprofloxacin was coated in microgravity, and I didn't want too little PVP because it would be hard to tell how well the ciprofloxacin was coated in microgravity, and I didn't want too little PVP because it might be hard to see the coating at all. I put the same solutions in our MDA apparatus for the ground truth experiment. Dr. Hendrickson and Dr. Rube and their team at Avika taught me how to use their scanning electron microscope to look at the samples 3 weeks after landing. I first looked at the liquid at the top of the sample called the supernatant liquid, or the liquid after everything else has settled out. For the control sample from the ground truth experiment, I found some coated ciprofloxacin in the supernatant. For the space sample, I found no ciprofloxacin in the supernatant. This is a complete opposite of my hypothesis because I thought that there would be coated ciprofloxacin in the supernatant of the space sample because it would coat more gently and slowly without gravity. I thought there would be less clumping or agglomeration in space, but these results tell me that there was agglomeration in the space sample. I looked at the sediment or sludge that sank to the bottom of the sample after it sat for a while. I expected the ground truth sample to have a not very efficient coating and for there to be extra PVP that did not have time to coat particles. And I expected the space sample to have a thicker coatings and be agglomerated or stuck together. On the left, in the ground truth picture, you can see there are very few spaces between particles that are filled with excess PVP coating. On the right, in the microgravity picture, you can see that there is excess polymer in between particles. So in space, instead of making a thicker coating, the PVP seemed to be sticking to itself, making a film. I also looked at the sample after shaking it or mixing it up. Again, I saw that in the ground truth picture, you can see that there are very few spaces between particles that are filled with excess PVP coating. While in microgravity picture, you can see that there is excess polymer in between particles. This tells me that the ground truth coated more efficiently than the results from microgravity, which was very unexpected. Finally, there was enough sample to run a thermogravimetric analysis, or TGA. This heats the sample and measures the mass of the sample. As the temperature rises, different substances burn off at different temperatures. First, some leftover moisture probably burns off. Then, in the ground truth, some of the sample of ciprofloxacin seems to burn off and the mass drops. Then, a lot of PVP burns off. The temperature of the ciprofloxacin and PVP burning off match fairly closely to the expected temperature from testing pure samples. But the surprise was the microgravity sample. We see the same burn of the moisture probably and the burn of the PVP, but no burn of ciprofloxacin, which means something different might have happened in space to make different complex. Lastly, I want to thank my school district, Lincolnwood School District 74 in Illinois, for making participation in SSEP possible. SSEP for this amazing opportunity, my science teacher, Mrs. Churchwell, and my mentors at Avika, Dr. Hendrickson and Dr. Rube, because without them, I would not have been able to design such an amazing experiment and the results, and I wouldn't have been able to find out the results to find out what happened.
All right.
Any questions?
Thank you for a great presentation. For questions, please come up to the microphone.
What made you think of doing microencapsulation for your experiment?
Well, first I actually started with oil and water, but I found out that the results would undo as they came back into gravity. So I actually looked through the packet of experiments that were done before, and I came across microencapsulation, and then Mrs. Churchwell actually tried to get someone to help me, and she came across Dr. Hendrickson at Avika, so then he helped me out, so that's why I started microencapsulation.
If you could redo this experiment, would you change your would you change the stuff that you used or not?
Well, I would try to use a different concentration to see if I could, if that way it would show me a better difference in the results.
What are you hoping to use the results for?
Well, it could be used for making, if the results were a success, they could have been used for making for coding antibiotics more properly.
All right, thank you. That was excellent. Thanks so much.
Thank you.